Cinema is a small explorer mission, and it's 9 small satellites. The goal of Cinema is to study the dynamics of Earth's magnetosphere. So we're looking at the night side magnetosphere where the magnetic field gets stretched out. And the idea is to study what are called auroral substorms when we see big auroral displays.
An aurora is essentially a glow of light that you see in the sky, and it's created when charged particles, electrons or ions, stream in from out in space and impact Earth's upper atmosphere. When they impact it, they heat it up and cause it to glow. The whole magnetosphere is full of plasma, so charged particles, and the energy is kind of moving through the magnetosphere. When the energy is moving through the system, it can either move kind of in a steady way, or it can move explosively. And also that's when we get the most spectacular auroral displays. Cinema is designed to study 3 different kinds of aurora. The first one is called a poleward boundary intensification, and we think that this is kind of the first step to that large-scale energy transfer in the magnetotail. The second type is called an auroral streamer. And these are interesting because they're aligned north-south rather than east-west. And these are thought to be connected to intense plasma flows out in the magnetotail. And finally, auroral beads. And those too often happen right before sort of the most explosive energy releases. Cinema is the first mission that is combining auroral imagery, magnetic field measurements, and particle detections on a constellation of satellites in low Earth orbit.
The particle detector and the magnetometer is gonna measure the dynamic of the same magnetic field line that is stretched all the way to the magnetotail. And at the same time, our camera is gonna take a picture on those aurora.
And it's going to be really amazing what we learn about our magnetosphere. But the data set that we're generating is going to enable the whole heliophysics community to do lots of other kinds of science.